Hi, welcome to Teaching Sample. The topic of this presentation is Dijkstra algorithm. This is me, Tarik Rashid. Well, actually, Dijkstra algorithm solves the single shortest path problem. Say, for example, when we have a graph and this graph contains several nodes and we're trying to find out the shortest path for this graph. Of course, the edges between these nodes must be non-negative. Now, the algorithm was found or coined by computer scientist Edgar Dijkstra. He was from Netherlands or Holland. And of course, we had one example last week and we solved it. But still, I would like to give you another example so that you can have a better understanding about this topic, as it is very, very important in searching algorithms. So the algorithm, we explained it last week, and you can take a graph, contains so many nodes or several nodes, and then you're trying to find out the shortest path. Very, very easy, and I try to simplify it in a good way. I try to make a good mental model for this algorithm. So this is the algorithm. We explained it, as I said. I'm not going through it, but you know it, and then we try to solve one of the problems using Dijkstra algorithm. So the problem is we have a diagram like this, and this is the mental model. So we're trying to find out the shortest path. Okay, say for example we have A node. Okay, starting A node, it goes to B with distance 2, and from B it goes to D with distance 2, and from A goes to D with distance 1, and D to E with distance 1, and E to F with distance 2, and so on and so forth. So we are trying to find out the visiting node, the shortest path. So starting from here, okay, the visiting node, say for example, if I am here, so I cannot get to anywhere because I'm not connected if I'm here, right here, this point. But here there's a red line, that means starting point, so I start from A. So I am in A, and the first node I'm visiting is A. So I'm putting the first node, A. I bring my pen here. A is my first node. Okay, that's A. And from A to A, it costs me nothing to move. So actually, I can put 0 weight or 0 distance and A. Okay, 0 distance and A. It means that I'm moving from A to A with no with no cost at all. So and I can put this one as a green color. That's the minimum distance that I have so far. So that I don't get confused. That's the minimum distance. Now I can go back to from A. I can go from A to B. So from A to B, this B, that's A. From A to B, it takes me 2 units of distance to move from A to B. So from A to B, I need 2 A I put. So 2 units of distance. Now from A to C, where C, that one is C. From A to C, 5 units. 5 units. 5 A. Okay. And from A to D, this D, so I need 1 unit. That's 1 and A. Okay, A to D. Very good. And from A to E, that's E, and this is A. So from A to E, there is no direct connection, so I cannot move. So not known, I put it down as a not known distance or edge. Now from A to F, likewise, from A to F, I have no direct connection. So N, F, NK, not known, or infinity. Now, you might ask, why A, why A, why A? Well, A stands for a visiting node. So you are in A, it means that you needed two units to visit B from A. From A, you need 2 units of distance to visit B. Okay, now, so I'll come to this row and I check which one is a minimum distance, which cell is a minimum distance apart from this one here. So I can see 2A, 5A, 1A, and NK not known, that's we don't know. So I believe 1A is the shortest or the minimum among other cells. So I'll go to put down 1A here, 1A here, 1A here, that's 1A. Now, then this is, it means that I am in D now. That is D. That is D. D, 1A. So from D, now visiting node, that's the minimum. I can put as a minimum so that I don't want to get confused later on in next step. So this is again in green. It shows that this is the minimum in this row. So from D to A, that's minimum, I don't touch it. And from D to B, from D to B, 2 distance. But earlier, I moved from A to D with 1 unit of distance. So 1 plus 2, 3. 1 plus 2, 3. So A, D, B, moving to B. So it gives me 3D. 3 from D. So, but I have earlier in my first step, it was 2A. So it's no better. I just ignore this move. I don't want to change the values that I have. So I just put down 2A. I stick my old value, which is better than the new value that I calculated a moment ago. So 2A now. And from D to C, let's see, do D to C. Now this is D, D to C, 3 unit, but from A to D, 1 unit. So 1 plus 3, 1 plus 3, it is 4. So 4 from D, 4 from D, 4 from D, 4 from D. This is much shorter. 4, 1, 3, 4, 1 plus 3, 4, D to C, so from D now. And from D to E, from D to E, D to E, 1 unit. So from D to E, 1 unit. But I started from A to D, 1 unit, plus D to E, another 1 unit. It means 2 unit. So I can put 2 and D here. D. D. So now, next move from D to F. From D to F. Well, I can't see any direct connection. There's no direct connection. So I can put it down as NK, which stands for not known. Okay, NK, let me write it down here. NK equals not. The mouse is very tricky. Now, not known. Very good. Not known. It's clear now. Now, next I try to find out the minimum distance. Come back to my subject that I was talking. The minimum distance in this row. 2A I have, 4D I have, 2D I have, 1A is already, I can't touch it, already in green. So apart from 1A, I have 2D and 2A. Now, here you have the choice to select either one of them. It's fine, but alphabetical tiebreak, so I go with alphabetical order. So for me, is B is better. So I put B, 2A here, 2A, and this is B. It's a long B, but anyway, it came like this. So that's as it is. I don't touch it. This one, hey, I forgot one thing. So I need to put this one in circle. That was my minimum in this row. I hope it's correct. So that's the minimum in this row. Of course, this is a very different green, so it should be the same color of green, so they don't get confused. Oh, sorry, what did I do? Anyway, don't. Okay. So that's the pen green. This one, fine, we are fine. Now slowly but surely we are there. Now from B to C, from B to C, let's see from B to C. Well, from B to C, it takes me 3 units to get to there. But earlier I start from A to D1, D to B2, so 3 plus 3, it means 6. Well, this is not good for me because I have already 4A, so I'm going to change and not, I stick with my old value, which is 4D. 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 That's correct. 4D. Right. Now from B to D, I don't touch it. It was the minimum 1A. And from B to E, there is no direct connection. B to E, that's E, and this is B. So there is no direct connection. I can stick with, or I can stick with 2D as it is earlier. It is better than not known. Okay. Then from B to F, again, not known. B to F, not known. I keep it as it is, not known, which is kind of infinity. So you can say this one is infinity, not known. Not known means infinity. Right. That's fine. And then I have check the minimum distance here. 2D, 4D, 2D is less. So I go with 2D, and it's node E. Of course, I put E here, node E. Now, from E, that's minimum, that's from E to C, this is E, and going to C, I'm here, I'm trying to go there. It takes me 1 unit, okay, cost to get there. So, but earlier I started from A to D and E, 1 plus 1 plus 1, that means 3, okay, that means 3. So 3 from E, okay, 3 from E is better than 4D. 1 plus 2 plus 1 plus 1 plus 1, 3. So it gives me 3E. Why? Because I am in my visiting node is E. Now, and then from E, D is the minimum, I don't touch it. From E to F, from E to F, well, from A to D, 1, from D to E, 1, that becomes 2, and from E to F, 2, so 2 plus 1 plus 1, 4. 4 E. Why? Because I start just from E. Now, coming back to find out the minimum among these values, of course, I should have put, I should have put here, I should have put green color here. Every time I put the minimum distance, I should circle it in green color. Circle it in green color. Now, the minimum among here, next step, the minimum among here is 3e. 3e, and I circled again so that I don't want to get confused. So circle this one. Now, of course, this is a node of C. So I visited A, B, D, E, C. Okay. Next, from C to D, it's done. We have it the minimum, and from C to E, from C to E, done. We don't have that's the minimum. We can't touch it. But from C to E, okay, let's do it from C to F. Sorry, from C to F. From C to F. From C to F. In the diagram, C to F. In the table, C to F. C to F. So from C to F, 5 units on its own. But I started from A, D, 1, D, E, okay, 1, okay, that is 1, 1, 1, 3, plus 5, 8. So 1, 1, 1, that's 3, plus 5, which is C to F, that's 8. So 8, 8C. Well, I don't need that because I have 4E. That's less than that. So I stick with 4E. Okay, stick with 4E. Now, here I have only this one minimum. I can bring it down. Okay, and this is not F. Okay, and I circled in green. Circled in green. So that's, I think, almost we are done with this problem. So if we just check, let's say we arrive at node F by 4E, arrive at node F by 4E, we'll check it. So 1, 2, and plus 2, that's 4E. But then we arrive at E, that's E, we arrive at E by 2D. Okay, this is node E. I arrive at this node by 2D. 1, 2. So 2D. Okay, but then from E, from D, I arrive at D. I arrive at D by 1A. I arrive at D by 1A, which is 1A. Okay, and then I arrive at A by 0A. So started from A and work out my way from A to A, 0A. So in other words, if I want to get to F, A, B, D, E, and F. A, D, E, and F. And you can find out for the rest of algorithm. So that's Dijkstra algorithm. Very simple, straightforward. Thank you very much. And if you have any problem, you can send me an email. The email was at the first title slide, so you can send me an email and we can discuss about Dijkstra algorithm. Thank you very much for listening and for your time. Thank you. Bye bye.